Okay. So this is, guys, yesterday, the correlated subqueries we started. Okay. And in this correlated subqueries, okay, to find out your first highest salary. Okay. So this is your statement of correlated subquery. But how it was working internally, the query execution process. Okay. The correlated subquery execution process will be, check it out. Okay, so yesterday, what is the table name? Employee. So this is table information, what we created. Blue shirt. Class started here. Okay, now you can see. So this is our table. So on this table, we return our query. How we return query? Select star from employee A1, where n-1 is equals to 0. Then after select count of distinct, okay, and column name was sal from. So employee A2. And what is our condition here? A2 dot salary, which is greater than A1 dot salary. So this is our the first highest salary. Employees details, sir. We got it. Okay. But how this query was executed, sir? Okay, now that we will see now. So this is my query request. Okay, this is our query. And I want to take this. Okay, right. Now, so now, can you remember self-join? We discussed in the join, self-join we discussed. Remember now? So when we created alias name on table, okay, what it was happen? When you created aliases on table, internally what happened? Internally system is created one virtual tables. Yes or no? So how many aliases we created on the table? That many virtual tables are created. That point remember now? So same as here, how many aliases I was created? E1 and E2. So on the name of two E1 and E2, two virtual copies are created. Okay, so I'm taking that virtual copies. The two virtual copies I'm taking now. Okay, right. So this is e name. This one is salary, salary, and e name. Okay, and now these are my aliases. So E2 and this alias was E1. And this is your information about the data. So 85, 24. So what is your information here? 85,000. Next. 24. Next. 48. Next. 85. Next. 67. Next. 11,000. Total 6 now. Okay. And here also okay, right. The two alias copies are we created. That's over. And later we said this n minus 1 formula, how it was came. Okay, so our formula is what now? N minus 1. So the solution of n minus 1 is what now? What is our solution? If n is equals to first highest cell means 1. If that was comparing here in the substitution of n minus 1, then what it was happen? 1 minus 1. So 1 minus 1 is equals to 0. So that means your outer query where conditional column. Okay. This is your outer query. Outer query where conditional value. How much was given here? 0. 0 is equals to, so outer query where conditional value is 0. 0 is equals to inner query. Now I want to execute. Understand? Na? So inner query, as per inner query condition, whatever the value will be returns, that means count value will be returns, that inner query count value will be matched with the 0, then condition true. If it is not matched with 0, then condition false. Understand? Na? Okay, I just keep it this 0 here. And the next one is here we are using count of distinct salary. So why I'm using count of distinct salary means to counting how many number of salaries are more than that. Okay. And in this counter, if any duplicate value will come as, the duplicate values are eliminated. That means don't count your duplicates. So that is what it was happen. Okay. And now I was taken this. And these are the countings I just taking here. Okay, fine. And now next one, outer query, okay, is already executed and it was return value of 0. Okay, outer query where condition value already 0. Now inner query will perform now. Inner query, what is your condition of inner query? E2 dot salary is greater than E1 dot salary. Carefully observe. Okay, na? E1 dot salary. So now in this condition, E2 dot salary greater than E1 dot salary. Now tell me, in these two aliases, which is outer, which is inner? Huh? E2, E1, in this two, which is inner, which is outer? E1, E2, inner. But correlated subquery first execution, outer. So that's why what you want to do, your comparison will be E1 to E2 comparison. Understand? Na? Why, sir, E1 to E2 comparison means this is outer query and your execution started from outer query. Okay. In correlated subqueries, what I said, your execution started from outer query. So that's why your comparison will be E1 to E2. Okay, fine. So E1 to E2 compare here, each and every value. Okay. Now first, 80, this is E1 na? Yes or no? This is E2. And now comparison, 85 compare with all values of a second alias table. Okay. So now I compare here. I compared here. Okay, all values. 85 is greater than 85. So now 24 I want to compare. Next I have to compare with 48. Next 85 will compare with 85. Next compare with 67 to 67. Next compare with 11,000 to 85. Okay. Now tell me, in this comparison, 85,000 above, because I'm using greater than symbol. So greater than means what now? Above. So 85,000 salary above is greater than above. How many salaries are there in my E2 alias table? 0. So 85,000 above. 85,000 above. Is there any salary in my E2 table? No. There is no salary. So there is a no salary which is more than 285. Understand na? There is a no salary which is greater than 285. No salary. So that means my count of distinct sal. How much it was written? 0. So my counting here I'm writing the count is 0. The count is 0. And this 0, this is called a inner query value. This inner query value, whatever it was written after checking of this condition, inner query condition checking after, whatever the value was came, that value I want to compare with the outer query. I'm comparing with what now? Outer query. Now tell me, 0 is equals to 0. Condition true or false? Condition true. At which value? 85,000. It written your as an output. Understand now? Like what happened? Not only one value. Each and every value I need to check. Okay. And the next one. Second one I am going to checking now. What is my second one here? What is my second one? Suppose I just go for 24 comparison start. 24 comparing with the all values of a second alias table. Yes. Now tell me, 24,000 above, how many values? One is 85, one is 48, one is 85, one is 67. These are the four values which is more than 224. Yes or no? Greater than 224. But in this 85 is called what? Duplicates. But you're counting of which keyword I'm using? Distinct keyword. Distinct keyword count. Duplicates are? No. So that means in this 185 don't count. That means now how many values are there which is greater than 24? 3 values. So the 3 values I am taking. The counting of 24,000. How many values here? 3 values. The 3 values I want to compare with my outer query result. So 0 is equals to 3. What do you say? Condition true or false? False. I just keep it this. Next one. 48,000 compare. When you comparing 48,000 with all values, okay, now check 48,000 above. How many values are there? 85 and 85, 67. But 185 don't count. Then how many? 2. So there are 2 values which is more than 248. The count is 2. And that count you need to check with your value. 0 is equals to 2. What do you say? Condition true or false? False. Next. 85. Now compare your 85 here. So in this comparison of 85, is there any value was there which is more than 85? No. No means count is 0. No means count is 0. Now here compare here. So 0 is equals to 0. Condition true or false? True. At which value? 85,000. Understand now? Next comparison. 67 compare. So 67 compare with all values. And in this comparison, how many values are more than that? 1, 2, and nothing. So 1 is recountable. And now only 1 was there. So here you will take only 1. And now compare with this. So what is this? 0, 0 is equals to 1. Condition true or false? False. Next in the same pattern. 11,000 compare. So 11,000 when I compare with each and every value, how many values are bigger than 11,000? 85, 24, 48, 85, 67. But in this duplicate, don't count. The remaining 4. Remaining 4. And the 4 I want to compare with this. 4, okay, 0 is equals to 4. Condition true or false? False. Okay, now? So this is the way it will be comparing. Understand, na? Comparing. In this comparison, so wherever your condition will be true, so where your condition will be true, in the first case true, in this case true. So now first highest salary employees, who is this? 85,000, the 2 people will come. Okay, now? Now in this correlated subquery, why performance will be degraded? Why it was giving low performance means, you carefully observe. Here inner query condition is checking. Yes or no? How we are checking? Tell me. 6 values into 6 values. Each and every value comparing a total 6 into 6, 36 times inner query condition will be compared. That is 36. Okay. After comparison of 36 times, this is your final values. Yes or no? Again, these final values, are you comparing with whom? 0. This is how many times? 1, 2, 3, 4, 5, 6. That means 36 plus 6. How many times? 42 times it will be checked. Got it? So 42 times internally your query will be checking. This is correlated. But the same thing, suppose non-correlated, I'm writing now. How you written non-correlated? Select a star from employee where sal is equals to offer. Select max of salary from EMP. Okay, now? So now in this, what I said, first inner query executed. Inner query executed returns how many values? Single value. What is the single value? Max salary. So this entire query will return how much value? 85,000. This 85,000 of what? Outer query next comparing. How to comparing? Select a star from EMP where salary is equals to 85. So compare now. So now this is your table. 85 is equals to 85. Condition true. 85 will come as. Next, 24 is equals to 85. False. 48 is equals to 85. 85 is equals to 85. True. Next, 67 is equals to 85. 11 is equals to 85. How many checkings? How many checkings? 6 checkings. Very good. 6 times checking. Correlated subquery? 42 times checking. So which performance is good? Non-correlated or correlated? Understand? Na? This is one of the interview question. In correlated and non-correlated, which will give a good performance, high performance. Otherwise, which performance is high? Means what do you say? Non-correlated. See, same requirement. First highest salary finding, first highest salary finding. Same requirement. In non-correlated subquery, 6 times comparisons, checkings. But in correlated, 42 times comparisons. Now see how much performance will be degraded by your correlated. Understand? Na? That's what I said initially. 99% of industry people, 99% of industry people prefer what? Non-correlated, not a correlated. 99%, even though somebody said 99.9% will prefer by people, which one? Non-correlated, because of performance wise very fast and correlated very slow. Understand? Na? But what I said, when we are writing some complex queries in non-correlated, there we should go for correlated, because I need to avoid a complexity. Maybe performance is degraded, but avoiding your complexity problems. At the time only you can go. Otherwise, which is not possible. Okay, the requirement is not fulfilled with the non-correlated. There the people will using correlated. These are the two cases only. Otherwise, don't touch correlated subqueries. Understand now? So this is the example and execution process. Now understand all of you how correlated internal executed? Yes or no? So this diagram I will send it to you, your Google Classroom. Okay, na? Right. So next, take next example. Write a query to find out fourth highest salary employee details. So what I said here, 4 means n minus 1 is equals to 3. So same query you have to take, but just I want to change my n minus 1 value, 3. Right. Okay. So now see, this is 3. Now the 3 comparison now. So compare 3. My outer query result 3. 3 is equals to first count how much? First count how much? 0. 3 is equals to 0. Condition true or false? False. Next count. 3 is equals to 3. Matching at which value? 24,000. So 24,000 is which highest salary? Fourth highest salary. Got it? Next remaining also compare. 3 is equals to 2. Condition true or false? False. 3 is equals to 0. Condition true or false? False. 3 is equals to 1. True or false? False. 3 is equals to 4. False. So where is matching? 3 is equals to 3. Which value? 24 is matching. Okay, let me see. The 24,000 is my fourth highest salary or not? Got it? Yes. Like you can find out any nth position of salary. Okay. Like how you find out your highest, even though we can find out your lowest also. One example I'm showing. So first lowest salary employee details. So first lowest means what I want to change here. N minus 1, how much? First lowest, n value 1. N value 1 na? N minus 1, 1 minus 1, 0. Why are you confused? N value, this is n value. Okay, this is your n value. Lowest or highest, but n value, how much? That you remember. So here, how much I'm finding? First highest. First lowest. First lowest means n value, how much? 1 only. The one substitute in n minus 1, how much? 0. Okay, 0, asterisk. But here I said, can you remember? Less than symbol for low salary, greater than symbol for high salary. So what I want to use here? In place of greater than, less than. That's it. Remaining all are same. And now I just go to execute this query. What it was happen, you can see. What is my first lowest salary in my table? 11,000. So that I got it. Understand now? Write down. One example, lowest also take. Okay, right. So these are nth, highest or lowest salaries, how to find out by using of your correlated subqueries. Okay. And along with correlated subquery, the one more way, this time, how to display, how to display, how to display top n highest or lowest salaries. Top n highest or lowest salaries. Everything will same, but my n minus 1 formula, n greater than. Okay, your n minus 1 formula will be changed. Right down below. And remaining same thing, less than is representing low salary, greater than is representing high salary. Okay, so on this, take one example. Write a query to display top three highest top three highest salaries, employees details. To display top three highest salaries, employee details. Okay, so now here also same, and now here observe. Here my formula n greater than. So that means now tell me I'm finding your top n. N place. How much here? 3. The 3 I want to substitute in place of n. So now here observe. When you substitute 3, suppose, carefully observe, my condition was 3 greater than, because n value directly n value 3, and that value I can directly substitute. So now comparison here. First one, how much here? 0. 3 greater than 0. Condition true or false? True. Condition true. Condition true means how much value returns? 85,000. Next step. 3 greater than, what is this? 3. 3 greater than 3. Condition false. Next step. 3 greater than 2. Condition true. At which value? 48,000. Next. 3 greater than, what is this? 0. Condition true. At which value? 85,000. Next. 3 greater than 1. Condition true. At which value? 67,000. 3 greater than, what is this? 4. Condition false. So now top 3 highest, what is this? Top 3 highest. 85, 67, 48. But here 85 people, 2 people are there. So that's why it was showing 2 times. Okay. Now you can write your query. How to write now? Select star from employee E1 where n value 3. 3 greater than of select count of distinct sal. Okay. From employee E2, where E2 dot sal is greater than E1 dot sal. So now the top 3 highest people 85, 67, and 48. Right down below. Okay, right. Same as now tell me top 3 lowest salaries. How to write now? Uh, where I want to give it here. Here so many people thinking what now? They will try here 3 less than. They're thinking like that. That's wrong. So n greater than is a fixed formula. So what I said, here you want to change. Here I said now, less than symbol, low salaries, greater than high salaries. So don't change here. Whatever you want to change, you can change here lowest, less than. Okay. But here the formula was fixed. And now you can come out and see the top 3 lowest salaries people. So who was there in the top 3 lowest here? So 11, 24, and 48. These are the top 3 lowest salaries. Write down. And your note point also write down along with this. What is the note point here? The first one. To find out nth, to find nth highest or lowest salary, then your formula depends on n minus 1. The second one, to display top n, okay, highest or lowest salaries, then my formula, what is our formula? N greater than. So these 2 points remember. Okay, right. So these are what now the correlated one way of mechanisms. Okay, and the next one right on here, exist operator. The next one takes heading exist operator. So here observe exist operator how to use in your correlated subqueries and when we want to use correlated. Okay, now exist operator is going to call as, guys, it is a one of the special operator we called. It is a special operator, okay, which is used in in correlated subquery only, which is used in correlated subquery. So that means existing operator I can't use into non-correlated. It was specially designed by people to using under correlated subqueries only. Okay. For what reasons? Okay. For what purpose we need to use this means to check. Purpose of existing operator is what now? To check a row is existing in a table or not. Okay, to check a row is existing in a table or not. Okay, then if a row is exist, if a row is exist, okay, if row is exist in a table, then it returns, what it will be returned? True. Otherwise it returns, what here? False. Okay, when your required row is existing in your table, then it returns true. If your row is not existing in the table, then it returns false. So main cause of your existing operator, just a checking your row, your required row is there or not there. If it is there, true. Not there, false. Now, okay, now that is the purpose of exist operator. And syntax right now. The syntax is what now? Where exist of my inner query. Okay, now? Right. And let me see the examples on this right now. Write a query to display department details, department details, in which department, in which department employees are, in which department employees are working. So I want to display department's details in which department employees are working. Okay, the query understand na? What is my query? I want to display what? Department details, but which departments, in which department employees are working. Okay, let me come. First of all, can you see this in my employee table? Okay, do you have any departments details? No, there is number, employee number, name, job, MGR, hire date, salary, commission, department number. So these are what now? Complete related to employee. But in this table, there is no department's details except a department number, but there is no other details here. So department details where it is, it means that in another table, the table name is what now? DEPT. So in this DEPT table, we have a department's details. So 10 accounting, new arc, 20 research, 30 sales, 40 operation. So now what I want to do, I want to display department details. Out of these 4 departments, your 14 employees are working under which departments? Those departments I want to show as and my output. Understand na? Here simple logic is there. So now we check it out. Number of employees 14. Number of departments 4. My question is what now? These 14 employees are working under which departments? Suppose these 14 employees, out of these 14 employees, some employees are working into accounting. Then condition true, accounting will come. Some employees are working research, condition true, come. Some employees are working sales, condition true, come. And suppose there is a no employee in operation, then condition false. Okay, now? So now first of all, what I want to do here, 2 tables, these are not single table, 2 table. So 2 tables, our required information, our required data comparison, what we are comparing, the data is having in the 2 tables. Employees data in 1 table, departments data in 1 table. So what I want to do? Our required data, when it was having in 2 tables, what I want to use to retrieve? Joins. Speak loudly. Joins. Okay, na? So here also I want to write which condition? First, join condition. So first I need to join these 2 tables data first of all. Got it my point? In this joining of 2 tables condition, what I said, whenever you need to join 2 tables, what should be required? Common column. Is there any common column in this 2 table? Can you check? Which one? Department number. Okay. In department number, employee department number, which departments are there here? 10 is there. 20 was there. 30 was there. Yes. 40? No. But in the department table, 10, 20, 30, 40 also there. Now, by seeing of this common column data, you can understand now, your 14 employees are working under accounting, research, sales. Anybody is there in operation? No. So that means my answer is account, research, sales. This is my answer. Okay. But how to write? How to check? Means then you have to use a exist operator. Now I'm writing select a star from DEPT D. D is what? Alias. Okay. Then after where which operator? Exist. Exist of inner query. Select inner query. What I want to retrieve department number from EMP E. Inner query condition is what now? Where E dot DEPT number is equals to D dot DEPT number. Careful observe. So now in this query, what it was happened, carefully see. First outer query is executed, that we all of you know. Outer query executed in the name of D. Okay. Outer query total result is what now? 10, 20, 30, 40. This is outer query result. Entire table will come because I'm using what? Star. Star means all columns. So select a star from DEPT. That means this entire table will come like this. After that, which operator I'm using? Exist. Exist of now inner query. Inner query as per this condition, department dot DEPT number is equals to DEMP dot DEPT number. What it is matching? 10 is equals to 10 matching. 20 is equals to 20 matching. 30 is equals to 30 matching. 40 is there? No. So that means 10, 20, 30. What I'm selecting here? What I'm selecting? Department numbers. What is this department numbers? 10, 20, 30 will come. This is inner result. Okay, now after inner result will come, then these results will be checking with my outer query result. Now 10 existing in your table. Yes, condition true. 20 existing in your table. Yes, condition true. 30 existing in your table. Yes, true. But is there any 40? No. So that means my answer is what now? 10, 20, 30. So this is just a checking of your existing operator, whether your row is there or not there. Okay. Let me go and check it out to right here. So now what happened? Research, sales and accounting, but operations are not showing. Okay, now right now. Okay, right. In the same question, in the negative manner, okay, display department details in which departments employees are not working. Employees are not working. So what I want to use here, not exist. That's it. How you say in, not in, between, not between, like, not like, is not null, is null, exist, not exist. Okay, na? So it is also one of the special operator. But this operator, especially we are using under correlated subqueries. That's why we are discussing here. Okay, now you can see the which one is not existing in my, okay, that is what now? Operational, okay, department. There is no employee is working. Okay, right now. This is negative operation. Okay, so these are the correlated subqueries, okay, and non-correlated subqueries, and these are entire your subquery types. Understand now? Hmm. So total how many categories here? Two categories. In two categories, five types we discuss. How many types? Five types. So in this first one, single row subquery, multiple row, multiple column, inline view, and correlated. Okay, na? Right. So along with these two things and two types of subqueries, in the latest versions, one more subquery is there. That subquery is called as your Scalar Subquery. Right down below. In the latest version, it was having here Scalar Subquery. Okay, so what is Scalar Subquery? And when we called a subquery is a Scalar Subquery means here observe. Here we all of you know the syntax of select a statement, select a star from table name. Okay, now this is general syntax of your select statement. So in this select statement, star means what? All columns. So that means in the place of star, can I write like this? Column name 1, comma, column name 2, comma, column name 3, and so on. Is it correct? Huh? So I can use the star, otherwise I can use all columns. So both are same. So this is also select statement. Okay. So now what I'm saying here, scalar subquery. So scalar is nothing but every single column is called as a scalar. Every single column is called as a scalar. So in place of columns, what I am writing? What I am writing? Subquery. In place of each column, I am putting, I'm keeping. What I'm keeping? Subquery I'm keeping. Then we called as a scalar subquery we called. Then we called as a scalar subquery we called. Okay. And every scalar subquery result. So this is one subquery. It returns some output. This is one subquery. Okay. It returns some output. This is one subquery. It returns some output. Okay. And whatever the scalar subquery results are there, these results are will show as, these results are will show as a column, as a column, as a column. Understand, ma'am? So every scalar subquery result will act as a column, will show as a column data. Okay, now, so that is what we called a scalar. So now I want to do, in place of this, what I am passing? Subquery 1. In place of column, what I am passing? Subquery 2. In place of column, I am passing subquery number 3. So in place of this, open brackets, closing, open, close, open, and close. Okay. So this is the scalar subquery syntax. That means how to write? Definition how to write? Providing subquery, providing subquery, providing subquery, providing subquery in place of columns, in place of columns, in select statement, in place of columns in select statement. And next one is what now? Every scalar subquery result will act as a column, will act as a column. And now this is syntax right now. Okay, now let me see some examples on this. First example here, observe. For example, come to suppose here two tables are there. One is DPT table having how many rows? 4 rows. Next one is what now? EMP having how many rows? 14 rows. For example, in each table, how many number of rows are there? It means that we are writing out the count of star from DPT. Same as I'm saying here, count of star EMP. These are individual queries. Now these individual queries I'm writing under selector statement. How I'm writing? Select, okay, count of star from DEPT. That is I'm showing as DEPT. Okay. I'm showing here number of rows. Okay, in DPT table, number of of rows of DEPT. So number of rows of DEPT. What is this? Alias name. So comma. Next I put it here. Select count of star from EMP. This is I want to say number of rows. Okay, in EMP. Okay, I put it this two and from here my table default table is what now? Dual. So now I'm executing here. What it was happening, you can see the number of rows in DEPT table 4, the number of rows in EMP table 14. And here, whatever the scalar subquery I return, this result of scalar subquery will show as a column. Is it column or not? See carefully. How it was showing? How it was showing? Columns wise. Understand na? So now this is one small example on scalar, how to work into column wise. Right down below first. Okay, right. So now take next example. Generally, this scalar subquery is where it will be useful. Okay, where it will be useful means, for example, let me come out and see. This is your employee table. So in this employee table, carefully observe, department number is a column. In this column, different numbers we have. Okay. If I said, or if I ask here, tens are there here, 20s are there here, 30s are there. This 10, 20, 30s. These are what? Rows are, columns are. rows. 10 is a row data. 20 is a row data. 30 is a row data. Column is what? Department number. So department number is a column, but 10, 20, 30, whatever the values are there, that is called as a row values. It's called a row data. Yes or no? Ah. So now what I want to do, whatever your 10 rows, whatever your 20 rows, whatever your 30 rows. So these are present in my table rows, but I want to convert as a column. 10 as a column, 20 as a column, 30 as a column. It means my row data I am converting into column wise. Understand now? Row data I'm converting. That means I'm showing as a columns wise. Row data I'm showing as a columns wise. Whenever you want to do like this, there you can use a scalar subquery. Let me see. You will understand. Okay. Select off. Don't write for subset. Select a sum of sal from EMP where department number is equals to 10. I'm showing as a column 10, comma. 10 is what? Alias name. Next I'm passing here. Select sum of sal. Okay. From EMP where DEPT number is equals to 20. And this is I'm showing as a 20. And next one. Select sum of sal. Okay. From EMP where department number is equals to 30. That I'm showing as a 30. From which default table? Dual. Now we can see. Okay. Directly key not from. It was taking as a integer type. So that's what I want to put. Okay. I want to put as string type. Okay. Now. So now what happened? You can see. So sum of salary of department number 10 is 8750. But it was showing as what wise? Columns wise. Actually 10 is what now? Row. But it was showing here column. So department number 10 is a column. Department number 20 is a column. Department number 30 is a column. So row data, this is row data actually. This row data, this is row data. This row data I'm showing as what now? Columns wise data with the help of department numbers. Okay now? So in that cases, your scalar subqueries you can use to convert rows into columns wise. Right down below. Okay. So Scalar Subquery, this is the latest subquery in your latest versions. And this is the reason of Scalar Subqueries, how to use it now. Okay, now. So these are your entire subquery topic. Okay. So total, how many sessions we spend on this? Huh? 6 or 7 or? How many sessions? Huh? Subqueries here, I'm asking. 6 huh? So total 6 classes we done. Huh? Exactly 1 week. 1 week sessions on subquery, because I said this is very big concept. So we send almost 6 classes on this. Okay, now? Right. Okay. And now, guys, here in SQL, how many languages we discuss? Huh? What is the first language we discuss? DDL. Next, DML. Next, DRL or DQL. Next, TCL. So these 4 language commands we worked. What is the next language? One more language is there now. What is this? DCL. So this is last language. So this language commands, if you finish it, then your SQL sub-languages commands are completed. SQL is not completed. SQL sub-language is completed. Remaining so much subject is there in SQL. Okay. So we said in introduction classes, we said SQL is having total 5 sub-languages. One is the data definition language, data manipulation language, data retrieval or query language, transaction control language. And next one is the data control language. Okay. If this language commands, what it was comes under in this? Anybody remember? Grant and revokes. Okay. So these these are the 2. Okay, now when these 2 commands are we finish it, then your SQL sub-languages all are we completed. Okay, only sub-languages commands are completed, but remaining concepts are so many are there. Okay, right. So basically, you observe data definition language. These are working on structure. Yes or no? These are working on structure. So structure creation, structure modification, structure table name changing, structure dropping. Yes or no? DML operations are working on data, data insertion, data updation, data deletion. DQL language working on reading data, how to read data from tables. TCL language commands are showing your transactions, how the transaction will make permanent or cancel. So that is called a yes or no. My transaction will be yes or my transaction will be no. So whenever user wanted your transactions to commit, then we are using commitment. If my transaction I don't want to commit, then I'm using rollback. That I said to you. If you do any online transactions through online application, after doing some steps, last one is there. That is called what now? Confirmation step. The confirmation, what it was say, either yes or no. Your transaction, are you confirm? Click on yes. Your transaction, are you cancel? Click on no. Yes means what? What happened here? You, 3 people only. Why smiling? Okay. Transaction may be success means committed. That means your transaction will be conformative. When you conforming means we are choosing S button. S button is nothing but committed. Suppose your transaction, I don't want to conform. I want to cancel. Cancel means no button. No means rollback. So these are the commands which was working on particular areas. So DDL commands are working on structures, only structure, but not data. Remember, DML commands are working on data, but not a structure. DRL commands are using for how to read data from your destination. Destination means your database. Your database is having somewhere, and the data how to read, that is telling by DRL. TCL means online transactions, how to managing by system. Okay, na? Sorry, managing by users. Either say yes or no. These 3 sorry, four language commands are developers must and should be needed. Developers have a compulsory this four language commands ideas. Okay, you have it now, then you will be do any transaction about a database. Developers means who was Java people, .NET people, Python people, okay na? Next, PHP people, okay. Next, database developing people, and some cases data science people, okay. Some cases like testing people, some cases AWS people, big data concepts working. Okay, these are some people are must and should need it. These four languages commands very well. If you know what is what, in what purpose we are using, you can easily develop your Java application. If you are Java developer, these four language commands are focus it. Okay. Then what about DCL language commands? These language commands who will use? So these languages commands are using by who? Developers. In real time, any developer, they must and should have a good knowledge on these four language commands. Okay, na? The next language is what now? DCL. So this language commands who will learn it, for what purpose learn it, who will use this in real time. Okay, now? So that we will see tomorrow. Okay, right, guys. So tomorrow we will discuss about DCL language commands, how to give permissions and how to cancel permissions. Okay, now? Right, guys. So thank you. Thank you so much. And online people, online people have any doubts, send your doubts. Aman already running notes uploaded.